climate change process is accelerating, and in response, international community takes on additional commitments towards reduction of greenhouse gas emission. According to the European Environment Agency information, EU 27 greenhouse gas emissions in 2019 declined by 24% compared to 1990 levels. The EU has a set target for 2030 of a 55% net reduction in greenhouse gas emissions. According to preliminary data, the EU's net emissions in 2020 were 34% below 1990 levels.
An organic soil, peat soil like here, is a highly dynamic system actually. Unlike mineral soils that sit there for thousands of years, slowly weathering, peat soil lives on the balance of decomposition and inputs of new litter.
To ensure the reliability and consistency of the greenhouse gas emissions data, there has been the framework under the United Nations Framework Convention on Climate Change developed. The Greenhouse Gas Inventory is the system for reporting and accounting of greenhouse gases emitted to or removed from the atmosphere. An inventory lists by sources the amount of greenhouse gases emitted to the atmosphere based on annual emission estimates from a base year to the latest year. Policymakers use inventories to establish a baseline for tracking emission trends, developing mitigation strategies and policies, and assessing progress.
A reliable and properly functioning greenhouse gas inventory system is the main tool to tackle the progress of greenhouse gas reductions and to assess the effectiveness of the greenhouse gas emission reduction measures. We observed a lack of consistent data on the realistic greenhouse gas emissions in organic soils internationally.
The OrgBalt project contributes with its activities.
Pētījuma galvenais uzdevums ir nodrošināt datus, kas nepieciešami, lai mēs varētu korekti aprēķināt siltumnīca efekta gāzu emisijas un oglekļa ienesi augsnē.
How comprehensive is the task to measure greenhouse gas emissions?
It's quite a complex issue because greenhouse gas emissions, they're not stable, they change over time, they change during a day. So therefore you need to measure constantly and for long periods to get a complete picture what happens there in the balance of the carbon stores and the greenhouse gas fluxes of the sites. You cannot only use one approach to measure all, so you have to develop different methods to measure.
In OrgBalt project, we are performing measurements in agricultural and forest land, with nutrient-rich drained organic soils, with different land use types and different moisture and other factor conditions. We are measuring three main greenhouse gas emissions: carbon dioxide, methane, and nitrous oxide, by performing soil heterotrophic respiration measurements using closed chamber method and photosynthesis measurements using transparent chamber method. In addition, we are measuring and sampling other environmental data, such as groundwater level and chemical composition measurements, soil temperature, moisture measurements, and soil chemical composition measurements. In parallel, we are measuring above ground and below ground biomass production, including fine root production, litter production, and decomposition by litter and biomass production. There are slight differences in measurements in agricultural lands and forest lands.
Mēs veicam trīs veidu gāzu mērījumus. Viens ir ar slēgtu necaurspīdīgu kambaru metodi. Mēs nosakām metāna un dislāpekļa oksīda emisijas gaisā. Mēs šos mērījumus veicam visu cauru gadu ar 3 nedēļu intervālu veģetācijas sezonas laikā un 6 nedēļu intervālu ziemas sezonā. Tad mēs mēram augstnes heterotrofā elpošanu. Tas ir mērījuma vietā, kur mēs esam novākuši visu veģetāciju, un mēs nosakām tikai to oglekļa dioksīda emisiju daudzumu, kas veidojās augstnes mikrobioloģisko procesu rezultātā. Trešā mērījuma grupa, ko mēs šeit veicam, ir fotosintēze. Arī veicam tikai veģetācijas sezonas laikā ar 3 nedēļu intervālu un nosakām oglekļa dioksīdu, ko absorbē augi fotosintēzes rezultātā.
Forest lands are subject of the same range of measurements as in agricultural lands. with several additional measurements and samplings, such as collection and analyzing litter from trees and plants, and biomass increase by moss production, as well as root socks installation for measuring the fine root production. For over 1 year in the live OrgBalt project, the greenhouse gas samples have been collected and analyzed in Tartu University laboratory. The chemical analysis of collected gas samples is performed by using state-of-the-art equipment called chromatograph.
I can sampling 60 bottles one by one. It takes 4 hours. Firstly, I put all this to the sampler and prepare this file with these names of these fields. And then analysis will start, but before that system clears all the pipes and look that everything is correct and there is no leaks.
There are several emission factors estimation methods to produce credible and traceable high-quality data for national greenhouse gas inventory. An emission factor allows estimation of greenhouse gas emissions per unit of activity. It is the average emission rate of a given source relative to units of activity or process. Other environmental data gathered on site helps to explain and understand the greenhouse gas emission factor. Number of studies enabling forming annual soil greenhouse gas balance for nutrient-rich drained organic soils has been relatively modest, despite of the importance of these soils as sink or source of greenhouse gases. The Intergovernmental Panel on Climate Change, as the United Nations body for assessing the science related to climate change, in 5th Climate Change Evaluation Report in 2014, included at that time available scientific data from 8 to 13 monitoring sites in the category of drained organic forest soils and temperate climate zone. Live OrgBalt aims to increase greenhouse gas data availability and to improve understanding on greenhouse gas emissions in nutrients-rich organic soils by gathering the data from measurements and samplings in 53 monitoring sites of the project, including 17 demonstration sites and 36 reference sites in different land uses and land use conditions. The project will contribute to more transparent, accurate, completed, comparable and consistent data to national greenhouse gas inventory, thereby supporting efforts to mitigate and adapt to climate change.